Okay, good morning everyone. So in this video we are going to solve this stone game 2. So I had solved this stone game 1 quite a while back. If you want to see that, definitely you can check that out. Look at what this problem number 2 of stone game says. So Alice and Bob continue playing with their piles of okay. There are a number of piles arranged in a row and each pile has a positive integer number of stones, let's say piles of I. The objective of the game is to end with the most stones. Okay, so Alice and Bob takes turns. Alice starting first, like the first problem. How do you pick up an element? So initially, M is given to you as 1, and on each player's turn, that player can take all the stones, the first X remaining piles. So let's say I am Alice and my M is initially 1. So okay, so let's complete the question and then I'll discuss. Okay, so the game continues until all the stones have been taken. Assuming Alice and Bob play optimally, return the maximum number of stones Alice can find. Now let's look at this example. So in we have 2, 7, 9, 4 and 4. Now M is set to initially as 1. Where is it? So I can take, since M is 1, I can take any number of piles starting this one that is between 1 and less than equal to 2 times M. So I can take basically the first two piles. Either I can take this or I can take this. Or I mean I take both of them. That's one way. In this case, either I can take the first element or the first two elements. M is 1. Let's assume we take the first two. So what is M? M was 1 in this case, and what was my X? X was basically 2 because I took two piles, right? So the max of 2 and 1 is what? Max of 2 and 1 is 2. So now time is for Bob to choose the number of piles. For him, since Alice took the first two elements, Bob can take what? The first four elements starting from 9 because M is 2, so X can be less than equal to 2M, right? So he can take at most 4 piles, at least one pile, or at most 4 piles. Assuming they are playing optimally, Bob will take all these remaining 3 elements. He can take that. So in the end, Alice would have 9 points and Bob would have 9 plus 4, which is 17 points. So Alice is like, so since I want to play optimally, I won't give Bob a chance to take these four elements, because if Alice chooses greedily the first two elements, Bob can take the remaining elements and win, because we need to return the maximum number of stones Alice can. So Alice is like, okay, since I cannot take two, what I'll do is I'll take a single element. So X is 1 and 2 times M. So when you maximize this, again Bob can take 2 piles at most. So okay, so Alice is like, I only will get 2 points and I'll pass the turn to Bob. Now Bob can take either 7 or, so in that case, let's say Bob chooses a single pile. So again, X and M both are 1. So then Alice would have a chance to choose these two piles, and she would definitely do, because 2 plus 9 plus 4 is greater than 7 plus. So 2 plus 9 plus 4 is what? 9 plus 4 is 13, 2 is 17. So Bob is like, if I only take the first pile, Alice would win, right? 15 points. But Bob is like, no, I don't want her to win. I want to maximize my profit, right? So now Bob is also playing optimally, right? So initially what was, she took the first two elements, Alice, and she got 9 points, and the remaining was taken by Bob. Now she has taken 2 and giving a chance for Bob to choose either 2 or a single element. So Bob sees that if he takes a single pile, he would lose definitely. Alice would take these two elements and she would win with 15 points. So Bob is like, no, I will also play optimist. Bob can play optimally, right? So Bob is saying, I won't take a single element, I'll take both. So now when the turn is of Alice, what she does is she takes, since X is 2, so the max of X and M would be 2. So when Alice takes the remaining, so the remaining number of piles Alice can take is 2 times of this new max, which is 4. So she could take basically 4 elements from starting from this position, and since there are only 2 left, she will take all of them, because piles are positive. Piles are having elements as positive integers. So Bob is like, oh, I'll definitely lose, but I'll take as many points as I could. So Bob takes this 7 and 9, which would give him 16 points, and Alice would get only 10 points. Although Bob wins in this case, but the maximum point you could get for Alice is basically 10. That's the max, and then if that is the case, you just sum up all the elements, subtract 10, and you will get, did Bob get. So similarly in this case, either can take the first two elements, and if she takes first two elements, then Bob is able to take the next four elements and he would win. So Alice is like, I'll only take a single element and I'll pass the turn to Bob. And Bob, what he will do, he can choose the first two elements or a single element, right? If he chooses a single element, Alice would again take a single element so that Bob can take at max these two elements, and in the end Alice would have the point 100. So that in that case Bob knows I cannot just take a single element because for sure Alice would get 100. So what he does is he tries to take the first two elements, and when he did that, Alice would get everything, right? So that is not something Bob wants. In this case, if he takes the first after Alice chooses a single one, and if Bob takes the first two elements, Alice would get what? 110 points. So he doesn't want that. So he's like, the minimum is when I just only take a 2, and Alice is like, I'll just take a 3, and then Bob anyway would have 4 and 5, and in the end Alice would take the 100. So 1 plus 3 plus 100 would give you output as. I hope this is not that easy to understand, right? Because it took me a couple of hours to question out exactly, and I have a solution, possible solutions, very well accepted and working fine. So let's look at this stone game too. Basically, I'm using a dynamic programming approach. So I get n, and I declare a DP array, a 3D DP array, but the space is n square plus n square times 2, 2 times n square basically. Now I get Alice points given this. Now let's look at what is this get Alice points function. So what it does is it takes an index at what point am I starting at, right? So since Alice could be starting from this point, this point, this point, so that is what we are trying to. Also the m is also at each iteration, right? Depending on this condition, I have to update my m. At every index, my m could also change and change my answer. Now finally, what I have to do is to check whose turn. Now clearly I can choose a boolean variable with Alice, or for that case I just, for the sake of, I just took an int. You could also take a bool because that would also work, but let's take int. Now let's look at the function. So it takes I, M and Alice. These are the index 3D DP array which declared as main function. So what we do is I say if the index that I'm pointing to currently is beyond the valid indices in the array. That means that regardless of where I'm starting, I can get 0 points regardless of the player, either Bob is playing or Alice is playing. If I am at an index where there are no piles or there are no stones, I in a way get 0 stones. Now the classic thing is, let's say if DP is this, you have not visited, or let's say if you have seen this instance sometime back, return that element. And what you do is you initialize Alice score as 0, and I'll just say why we are doing int max. So let's initialize that to 0, and I'll initialize the total score to 0. Now let's start x from 0 to less than 2 times m. Although we have 1 and 2m, I'll just subtract 1 from it, and later on when we have to do this operation, this maximizing operation, I'll just add 1 to it. Now I find the next index. Now again, if this index is beyond what is in my, let's say, number of elements in my piles, so that means I do not have any valid solution beyond that. I just break out of this. Otherwise I get total score. Basically I'm taking that the first x, right? I'm trying to take the first x piles as my score and then calling recursively to find the remaining. So what I do is, let's say I'm at index x, I get the new index, and if there's a valid index, this array, then I initialize this total score to. So this total score is basically carrying all the piles I have taken from starting from index I till I plus x minus 1, or basically I plus x in this case. So this capital X is still right from 1 to 2m. So this total score is representing all the piles that I've taken starting from index I, and I'm saying that if it is the turn of Alice, so I'll take that whatever the max I got for Alice, right? Or I could do is total score whatever the number of piles I could collect till now, and I could recursively call for the next index, right? I've taken this into consideration, an index, new index is taken into consideration. So what I would do is I would take that is my current score for Alice plus the maximum score I can get when the turn is for Bob. So when we have the turn of Bob, so what is the maximum he got? So m is just this as just given. I'll just use the same formula. The index is new index plus 1 because till new index taken that into consideration. So the index after that, I'll tell the next player to start from this index, new index plus. Now I change the player's turn by this and just pass the piles and the DP array and try to maximize the score that Alice could. Let's say if we did not call for Alice, that means we called for Bob, this function. So what it will do is we have to minimize the score, right? So since when we called for Alice, we initialized this value to 0 because we need to maximize this. So we need a smaller value, a lower limit for the score of Alice. Otherwise, since we are calling for Bob, that means I'll take the value as int max and I'll do this, and I'll not use the score because the score is for the Alice and we are not trying to calculate the score of Bob. So what I'm doing is I'm just basically trying to call this one on Bob, trying to get the maximum points Alice could get, given that Bob is also playing optimum. So why minimum? Because Bob, what does Bob want? Bob wants to maximize his profit, or in other words, or if he could minimize Alice's point, his score would automatically be maximized. So that is why this max and min, and depending on the max and min function, we are initializing this to 0 and int max. Similarly, I'll call this for next element, assuming this total scores is taken by Bob, so we don't include that into our answer when we are calling this for Bob, right? Because I'm assuming that this score is for Bob. I'm not storing it somewhere. I'm just saying that this score is. Now basically what I do if initialize this max again and I change the turn back to Bob Alice. When we are here, that means we are processing Bob. So when not of Bob is basically Alice, pass this files and DP. Whatever is the answer to this, I'll just initialize that to my DP array so that I do not do this calculation again. And what is the end result is you return this get Alice points starting from index 0 of the list. Your M is initialized to 1, right? M is initialized to 1 and the turn is off. You pass piles and DP just as a vector so that this function can refer that. Now if you see n is the pile size, DP would be size n. For the array index, the second would be the n plus 1 because m starts from 1, right? So m could go from 1 to the last index. So that is what I'm trying to do. I'm initializing this plus 1 because m is starting from 1 and not, and I have 2 basically denoting the turn of Alice or Bob and initializing everything to minus. Now you can convert this memoization solution to a tabulation solution. And what's the time complexity and space complexity? Space complexity is basically order of n square, although you could say that order of 2n square. You don't basically consider the constant in this big O notation. Okay, so the order is of n square, and how many times function is being called is for all i's and all m's. So basically I stands for I is for n elements, m is for n elements as well. So n square, and for each and every element in the first case we are doing a linear iteration of n. So n square times n, nearly about n cube is the time complexity of the solution, and the space complexity is n square. For some reason you don't use this DP array, the time complex explode exponential. So yep, that was the whole video all about. Hope I was explaining you. This question is a bit tricky and it's normal if you don't understand to go. So yep, that is the video, and I will see you in the next video.